Good evening. I hope everybody can see my screen. So it says realization of Fir and IR filters. If anybody couldn't hear me or see my screen, let me know. Okay. So today we are going to look at the fourth module, which is the realization of Fir and IR filters. If you compare all the modules in our DSP syllabus, I would say this is the most easy module because it's some drawings where you are going to say that the structure of the filter looks like this, okay, or structure of the digital filter looks like this. So we are going to see how an Fir and IR filter looks like using some blocks in a digital system. Okay, so as you all know, you have a digital system which has an impulse response h of n. It has an input x of n, which gives an output y of n, which is equal to the linear convolution of x of n and h of n. Okay. Now, your y of n, you can express it as a linear combination of previous input, previous output, previous and present input. ഇതാണ് ഒരു y of n ലേക്കുള്ള general equation. Okay. IIR filter equation ആണ് basically ഇത്. But in general, you can say it like this. If all the AK values is 0, that means you don't have this term, then this becomes the equation of an Fir filter. But in general, you can say y of n looks like this. So if you take the set transform of y of n, that is y of z, using this formula, then wherever there is a shift, it is equivalent to multiplying it by z raised to minus of that shift. So y of n minus k is equivalent to, when you take the set transform, the product of y of z multiplied by the shift z raised to minus of that shift. Similarly, x of minus k, the set transform will be x of z, which is the set transform of x of n, multiplied by the shift. So now you can take this part to this side on the left hand side. So you'll get y of z into 1 plus sigma k equal to 1 to n ak z raised to minus k, where we have taken out y of z outside, is equivalent to x of z sigma k equal to 0 to m bk z raised to minus k. Or in general, your digital transfer function h of z is equal to y of z divided by x of z. That is equal to sigma k equal to 0 to bk 0 to m bk z raised to minus k divided by 1 plus sigma k equal to 1 to n ak z raised to minus k. ഇതാണ് h of z ന്റെ general equation. Okay, where bk are constants, ak are constants, and z raised to minus some value is actually a unit delay. കാരണം y of n minus k യുടെ corresponding ആണ് z raised to minus k. Okay, അപ്പോൾ y of n minus 1 ആയിരുന്നെങ്കിൽ this would have been y of z into z raised to minus 1. So z transformile z raised to negative of a number is equivalent to a delay in the corresponding time domain. Okay, so ഈ ന്യൂമറേറ്ററിൽ കാണുന്ന വാല്യൂസ് z raised to minus k വാല്യൂസ് എന്ന് പറഞ്ഞാൽ x of n ന്റെ ഡിലേസ് ആണ്, മൾട്ടിപ്ലൈഡ് ബൈ എ കോൺസ്റ്റന്റ് ബി കെ. ഡിനോമിനേറ്ററിൽ കാണുന്ന ഈ വാല്യൂസ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ബേസിക്കലി y of n ന്റെ ഡിലേസ് ആണ് and multiplied by ak. So if you look at this equation, you can see that there are delays in this equation, or there's a unit delay. ഇപ്പോൾ ഡിലേ 2 വേണമെന്നുണ്ടെങ്കിൽ you can delay it twice. For example, z raised to minus 2 is equivalent to saying it is z raised to minus 1 multiplied z raised to minus 1. എന്ന് വെച്ചാൽ യൂണിറ്റ് ഡിലേ, if you apply it twice, you will get a 2 unit of delay. Similarly, if you want to have n units of delay, you just apply it n times. Z raised to minus 1 into z raised to minus 1 into up to z raised to minus 1 n times. That is unit delay. Apart from this, the equation has multiplications with the constant bk, scalar multiplications with constant bk in the numerator and ak in the denominator. And there are something called as adders. Summation blocks is also there. So if you are going to realize, or if you are going to implement this filter in a digital system, the system needs a unit delay elements, multiplication elements, and adder elements. So thus, to realize h of z, we need delay, multipliers, and adders. These 3 blocks are called as the basic elements of a digital system or a digital filter. Delay, multipliers, and adders. ഏത് തരത്തിലുള്ള ഡിജിറ്റൽ സിസ്റ്റം ഇംപ്ലിമെൻറ്റ് ചെയ്യാനും നിങ്ങൾക്ക് ഡിലേ വേണം, ഒരു ഡിലേ എലിമെൻറ്റ് വേണം. അതായത് ഒരു യൂണിറ്റ് ഡിലേ കൊടുക്കാൻ പറ്റുന്ന ഒരു ബ്ലോക്ക് വേണം, ഒരു മൾട്ടിപ്ലയർ വേണം, ആഡർ വേണം. So what we are going to do is, we are going to represent this h of z in different ways. Digital filter പ്രാക്ടിക്കലി ഇംപ്ലിമെൻറ്റ് ചെയ്യുമ്പോൾ അതിൽ ഡയഗ്രമാറ്റിക്കലി നമുക്ക് എങ്ങനെ റെപ്രസെൻറ്റ് ചെയ്യാം, അതാണ് നമ്മൾ കാണാൻ പോകുന്നത്. So this diagrammatical representation can be using a block diagram. You might have studied in control systems, block diagrams, and signal flow graphs. Okay, and this realization is important in physical implementation of discrete system. അതായത് നമുക്ക് ഇതൊരു ബ്ലോക്ക് ഡയഗ്രാം യൂസ് ചെയ്ത് റെപ്രസെൻറ്റ് ചെയ്യാൻ പറ്റുമെങ്കിൽ ആക്ച്വൽ ആയിട്ടുള്ള ഹാർഡ്വെയറിലേക്ക് ഇംപ്ലിമെൻറ്റ് ചെയ്യുമ്പം ഇറ്റ് വിൽ ബി മോർ ഈസി. Similarly, the basic elements like adders, delay elements, and multipliers are used for realization. So now, how do we represent delay, multipliers, and adders in using a block diagram and using a signal flow graph? That is the question that is given below. ഒരു ആഡർ എന്ന് പറയുന്ന എലിമെന്റ് ആണെങ്കിൽ that is represented as a plus. Okay, so x1 and x2, both the signals or both the values are going to the plus sign. It is x1 and plus x2. സിഗ്നൽ ഫ്ലോ ഗ്രാഫിൽ ഇറ്റ് ഈസ് ജസ്റ്റ് എ നോഡ്. ഈ നോഡിലേക്ക് 2 സിഗ്നൽ വരുന്നുണ്ടെങ്കിൽ ബേസിക്കലി ഈ നോഡിൻ്റെ ഔട്ട്പുട്ട് എന്ന് പറയുന്നത് x1 of n plus x2 of n ആയിരിക്കും. ഇനി കോൺസ്റ്റന്റ് മൾട്ടിപ്ലയേഴ്സ് യു റെപ്രസെൻറ്റ് യൂസിങ് എ triangle pointing to the right, just like an op-amp, and you write the value either inside or outside. So x of n, when it passes through this block, the output is a into x of n. Similarly, in signal flow graph, you will represent it as an arrow, and over this arrow you will write what value it is. So x of n is equal to, when it passes through this, it is a into x of n. Unit delay means when you pass x of n to a block which is represented as z raised to minus 1, the output of this block is x of n minus 1. It means that it has delayed by 1 unit. So the representation of the unit delay is z raised to minus 1. Or in general, in signal flow graph, you represent it as an arrow. On the top of the arrow, you have z raised to minus 1. So x of n is x of n minus 1. Similarly, if it is unit advance, x of n, when it passes through a block with z, it is x of n plus 1. Okay, and x of n in signal flow graph is an arrow over which you write z, which means the output is x of n plus 1. So using these basic blocks, you can construct or you can represent any form of the equations, IAR or FAR, whatever be the equations. So just to show you how it is represented, let's say you want to draw the block diagram and signal flow graph of y of n is equal to 0.4 y of n minus 1 plus s of n minus 3 into x of n minus 2. ഇതിൻ്റെ ഒരു ബ്ലോക്ക് ഡയഗ്രാം ആണ് വരയ്ക്കേണ്ടത്. ഇങ്ങനെ ഒരു ബ്ലോക്ക് ഡയഗ്രാം വരയ്ക്കണമെങ്കിൽ ആദ്യം യു സ്റ്റാർട്ട് ഇറ്റ് ഫ്രം എക്സ് ഓഫ് എൻ വാല്യൂ. സോ എക്സ് ഓഫ് എൻ will be added or subtracted from minus 3x of n minus 2. So x of n should be delayed twice to get x of n minus 2. That should be multiplied by 3 and that should be subtracted from x of n. So if you look at this block, you have x of n. You delay it twice. The first delay will give you x of n minus 1. You delay it again. The second delay will give you x of n minus 2. Now you want to multiply it with minus 3. So after this, if you have a multiplier block minus 3, then the output which is coming here is minus 3 x of n minus 2 at this point, which will go to this adder. Now if you look at this equation, x of n is added with minus 3 x of n minus 2. So you have an x of n which is coming here, which is added with minus 3 x of n minus 2. So you got at this point this part. Okay. Now the other part, to represent the other part, you started from the output. y of n ന്റെ പാർട്ട് റെപ്രസെന്റ് ചെയ്യാൻ നിങ്ങൾ ഔട്ട്പുട്ടിൽ നിന്ന് സ്റ്റാർട്ട് ചെയ്യുക. കാരണം നിങ്ങളുടെ ഈ ഒരു പോർഷൻ എന്ന് പറഞ്ഞാൽ ഔട്ട്പുട്ടിനെ ഒരെണ്ണം ഷിഫ്റ്റ് ചെയ്തിട്ടുള്ള പോർഷനാണ്. സോ യു സ്റ്റാർട്ടഡ് ഫ്രം ദ റൈറ്റ് മോഡ് സൈഡ് ആൻഡ് യു വർക്ക് ടുവേർഡ്സ് ദ ലെഫ്റ്റ്. റൈറ്റിൽ നിന്ന് ലെഫ്റ്റിലേക്ക് വരിക. എക്സ് ഓഫ് എൻ്റെ കേസിൽ ലെഫ്റ്റിൽ നിന്ന് റൈറ്റിലേക്ക് പോവുക. വൈ ഓഫ് എൻ്റെ കേസിൽ റൈറ്റിൽ നിന്ന് ലെഫ്റ്റിലേക്ക് വരിക. ഓക്കെ. സോ വൈ ഓഫ് എൻ ഇസ് ഹിയർ. You need y of n minus 1, which means you need to delay y of n by z raised to minus 1. You will get y of n minus 1. Then it is multiplied by 0.4. So you have a 0.4 multiplier. So the thing that is reached here will be 0.4 y of n minus 1, which will be added with whatever is coming from x of n minus 3 x of n minus 2, which is happening here at this adder block, which will be your output y of n. That's all. അപ്പം എപ്പോഴെങ്കിലും സിഗ്നൽ ഫ്ലോ ഗ്രാഫ് അല്ലെങ്കിൽ ബ്ലോക്ക് ഡയഗ്രാം വരയ്ക്കണമെങ്കിൽ എക്സ് ഓഫ് എന്നിൻ്റെ കേസസ് വരയ്ക്കാൻ വേണ്ടിയിട്ട് യു സ്റ്റാർട്ട് ഫ്രം ദ ലെഫ്റ്റ്. യു ഫൈൻഡ് ഔട്ട് ഹൗ മെനി ഡിലേ എലിമെൻറ്റ്സ് ആർ നീഡഡ്. യു ഡ്രോ ദ ഡിലേ എലിമെൻറ്റ്സ് in the bottom. Okay, you put enough number of adders and you add with x of n if it is needed. Y of n കേസിലാണെങ്കിൽ you start from the right, you add enough delay elements to the bottom, then if it needs multiplication, you add the multiplication as a branch, then you add with whatever is coming from x of n side. That is your y of n. Signal flow graph is a bit more similar. You have x of n, you put a z raised to minus 1, so this node will be x of n minus 1. Again you put a z raised to minus 1, this node will be x of n minus 2. So this should be added with x of n, which means you just bring the node here. Now for y of n, so this is y of n, you start from the right, so you need to have z raised to minus 1. So pass through z raised to minus 1. Okay, so the node coming here will be the combination of x of n minus 0.3 x of n minus 1, and so you need a multiplier also there. Okay, which when it goes out it will be y of n. Okay, so this is a simple block diagram. ഇങ്ങനെയാണ് ബ്ലോക്ക് ഡയഗ്രാം വരയ്ക്കേണ്ടത്. പക്ഷേ ഇത് കുറച്ചുകൂടി സിസ്റ്റമാറ്റിക് ആയിട്ട് വരയ്ക്കണം. സോ അഗെയിൻ IAR ആണെങ്കിലും FIR ആണെങ്കിലും it needs to be drawn properly or in a systematic way. So first we are going to look at, okay, let me just correct this mistake here. So this is x of n minus 1, x of n minus 2. So let me just put as minus 3. So that is correct. Fine.
Sir,
Ah,
no. Or doubt.
കേക്കാവോ?
So doubt.
പറഞ്ഞു.
Z raised to minus 1 block.
ആ,
Z raised to minus 2 എന്നിടാവോ?
minus 2. Okay, what I will do is I will just modify this equation. Okay, so let me say my equation is something like this. Plus 2 into x of n minus 1 minus 3 into x of n minus 2. ഇങ്ങനെയാണെന്ന് വിചാരിക്കാം. Okay, so in that case, you see that after x of n minus 1, you have a multiplier with x of n minus 2. Okay, so if you look at this signal flow, x of n minus 1 ഇവിടെ വരുന്നു, താഴേക്ക് പോകുന്നു. There is a delay of z raised to minus 1, which will give me x of n minus 1. Okay, and there is a delay here, which will give me x of n minus 2. Okay, now, പക്ഷേ x of n minus ന്റെ കൂടെ you need to add 2, sorry, multiply by 2, which will get added with minus 3 into x of n minus 2. Minus 3 into x of n minus 2 already ഇവിടെ വരുന്നുണ്ട്. So if I put an adder block here, and if I add here with this branch of x of n minus 1, then basically it is equivalent to adding x of n minus 1 minus 3 into x of n minus 2. That means if I do something like this, 2 is here, plus is here. So this x of n minus 1 at this point is multiplied by 2. So whatever is coming here is 2 into x of n minus 1. And whatever is coming from this branch is minus 3 into x of n minus 2. So whatever is that we are getting here, sorry, here is 2 into x of n minus 1 minus 3 into x of n minus 2. So I have already an x of n coming here. So when I add with 2 into x of n minus 1 minus 3 into x of n minus 2, so at this point you will get this part. ഇതായിരുന്നു ഡൗട്ട്. ആ,
അതല്ല, ഞാൻ ഉദ്ദേശിച്ചത് ഇപ്പം 2 ബ്ലോക്ക് ഇട്ടല്ലേ,
ഒന്ന്
അതിന് പകരം രണ്ടും കൂടെ ചേർത്ത് Z raised to minus 2. ഇതിപ്പം ഒരു Z raised to minus 1 ഇട്ടു,
ആ,
പിന്നെ അതിന്റെ ഔട്ട്പുട്ട് വാല്യൂ.
ഓക്കെ, ഓക്കെ. എൻ്റെ അതായത് എനിക്ക് മനസ്സിലായത്, അതായത് ഇത് രണ്ടും കൂടെ കൂട്ടിച്ചേർന്ന് വൈ കാൻ വി പുട്ട് ഇറ്റ് ആസ് എക്സ്ട്രാ റേസ് ടു മൈനസ് 2, അതാണോ ചോദ്യം? Okay, so you can do that if there is no such term like this. That is okay, but conventional way you will represent both z raised to minus 1 in a two different block. അതാണ് conventional way. We don't show it as z raised to minus 2 കാരണം നമ്മുടെ ബേസിക് എലമെന്റ് എന്ന് പറയുന്നത് യൂണിറ്റ് ഡിലേ ആണ്. ഒരു സിംഗിൾ ഡിലേ ആണ് ബേസിക് എലമെന്റ്. z raised to minus 2 എന്ന് പറയുന്നത് നമ്മുടെ ബേസിക് എലിമെന്റ് അല്ല. ഓക്കെ, നമ്മുടെ ബേസിക് എലിമെന്റ് z raised to minus 1 ആണ്. So we'll try to make sure that we represent the whole blocks using only basic elements. Okay, mathematically or technically that is correct. You can put z raised to minus 2, but what you call in a conventional way it is not correct because the basic element is z raised to minus 1. Clear ആയോ?
Okay, sir.
Okay, good. Okay, so we'll go to realization of FIR filters. First one. So the FIR filters can be realized in two ways. One is called as direct or transversal realization, and second is called as cascade realization. Okay, so in direct form, again, we look at the general form of h of z in z transform, that is sigma n equal to 0 to n minus 1, h of n z raised to minus 1. So if you expand this, we get as you substitute n equal to 0, it is h of 0 z raised to 0, which is 1, n equal to 1, h of 1 z raised to minus 1, n equal to 2, h of 2 z raised to minus 2, up to n minus 1. You will get the values. Now, h of z is actually y of z by x of z. Okay, so you can cross multiply. You can take x of z to the right hand side. So I can write y of z is equal to x of z multiplied by this whole thing. If you take x of z inside and take the inverse Fourier z transform, y of z will become y of n. H of 0 into x of z will become x of n. H of 1 into z raised to minus 1 into x of z will be basically the delay. H of 1 into x of n minus 1 plus up to h of n minus 1 into x of n minus 1. ഇതിനെ represent ചെയ്യാൻ it is bit more simple. So what you want to do is you have x of n, you multiply by h of 0, you delay x of n by 1, then you multiply it by h of 1, only that x of n minus 1, and goes on. So you can say, let's say this is x of z or x of n. Okay, you delay this, so you will get here x of n minus 1. So this x of n, when it goes through here, it will be multiplied by h of 0. So whatever you get here is either it is, you can say it as x of z into h of 0 or x of n into h of 0, whichever domain you are taking. So this x of n minus 1 will get multiplied by h of 1. So at this juncture, you get x of z into h of 0 plus z raised to minus 1 into h of 1, or h of 0 into x of n plus h of 1 into x of n minus 1. ഇതാണ് ഈ ഒരു ജംഗ്ഷനിൽ കിട്ടുന്നത്. Similarly, you delay it again. So this is x of n minus 2. You multiply by h2. So this is h of 2 into x of n minus 2 here. So this you are adding with the previous terms, this one. So which you will get this also added to this part. Okay, so at the end y of n will be this equation. But direct formula ചെയ്യാൻ പറഞ്ഞു കഴിഞ്ഞാൽ you just draw the delay block on the top, you draw the adder block at the bottom. Each leg of the before the delay block or after the delay block will be your h of 0, h of 1, h of 2, or the h coefficients. That's all. ഇത്രയേ ഉള്ളൂ ഡയറക്റ്റ് ഫോം റിയലൈസേഷൻ. ഓക്കെ, ഡയറക്റ്റ് ഫോം റിയലൈസേഷൻ എപ്പോഴും ഈ ഒരു ഫോമിലായിരിക്കും, ഇതായിരിക്കും സ്ട്രക്ചർ. ഇതിൽ നിങ്ങൾക്ക് എച്ച് ഓഫ് സീറോയുടെ വാല്യൂ, എച്ച് ഓഫ് വണ്ണിൻ്റെ വാല്യൂ, എച്ച് ഓഫ് ടൂയുടെ വാല്യൂ, എച്ച് ഓഫ് എൻ മൈനസ് വണ്ണിൻ്റെ വാല്യൂ മാത്രം സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താൽ മതി, വേറെ ഒന്നുമില്ല. ഒരു എക്സാമ്പിൾ കണ്ടാൽ യു അണ്ടർസ്റ്റാൻഡ്. Obtain the direct form realization of h of z, where h of z is 1 plus 2 z raised to minus 1 minus 3 z raised to minus 2 minus 4 z raised to minus 3 plus 5 z raised to minus 4. ഇതാണ് നിങ്ങൾക്ക് വേണ്ടത്. എത്ര ഡിലേ എലിമെന്റ് ഉണ്ട്? 1, 2, 3, 4. So you first draw the delay elements in a single line. ഒരു ലൈനിൽ 4 ഡിലേ എലിമെന്റ് വരയ്ക്കുക. ഈ 2 ഡിലേ എലിമെന്റിന്റെ നടുക്ക് യു പുട്ട് ആൻ ആഡർ. Okay, then you connect all the delay elements and you connect the line joining the delay elements with the adder. Basically, you will get a T shape like this. And you connect all the adders. Okay, and you connect from x of z or x of n to the adder. ഇനി z raised to 0 മുതൽ അങ്ങോട്ട് you give the values. So 1 will come here, 2 will come here, -3 will come here, -4 will come here, +5 will come here. That's your direct form realization. ഏറ്റവും ഈസി ആയിട്ടുള്ള റിയലൈസേഷൻ ആണ് ഡയറക്റ്റ് ഫോം. ഓക്കെ, സോ ഇറ്റ് മൈറ്റ് ബി പോസിബിൾ ദാറ്റ് സം ഓഫ് ദ ഡിലേ എലിമെന്റ്സ് വിൽ ബി 0. ഫോർ എക്സാമ്പിൾ, ഇപ്പോൾ ഇതില്ല എന്നുണ്ടെങ്കിൽ ഈ ഒരു ബ്രാഞ്ച് ഉണ്ടാവില്ല. റെസ്റ്റ് ഓഫ് ദം ആർ സെയിം. ഓക്കെ, we will see one more example. Direct form realization of h of z is equal to 1 minus 1 by 4 z raised to minus 1 plus 3 by 8 z raised to minus 2 multiplied by 1 minus 1 by 8 z raised to minus 1 minus 1 by 2 z raised to minus 2. ഇങ്ങനെ ഒരു ഫോമിലാണ് തന്നിരിക്കുന്നതെങ്കിൽ രണ്ട് ടേം തമ്മിൽ മൾട്ടിപ്ലൈ ചെയ്ത ഫോമിലാണ് തന്നിരിക്കുന്നതെങ്കിൽ you remove the brackets, means you cross multiply. Okay, so 1 into 1 is 1, 1 into minus 1 by 8 z raised to minus 1. So you cross multiply and bring to this form. ഈ ഫോമിൽ കൊണ്ടുവരാം. ഇതാണ് സ്റ്റാൻഡേർഡ് ഫോം. ഈ സ്റ്റാൻഡേർഡ് ഫോമിൽ കൊണ്ടുവന്നിട്ട് you do whatever was told earlier. You find out how many delay blocks. 1, 2, 3, 4. So you draw 4 delay blocks. 1, 2, 3, 4. You connect all the delay blocks. Okay, then you have an adder at the bottom. So 4 delay block ഉണ്ടെങ്കിൽ 4 adders വരും. And you connect the delay blocks and the adder, the line joining the delay blocks and the adder with a multiplier. Okay, ഒരു multiplier വെച്ച് connect ചെയ്യും. And you connect the x of n to the first adder with a multiplier. Then you write h of n in that order. So first one here, minus 3 by 8 come here, minus 3 by 2 comes here, 5 by 64 comes here, minus 3 by 16 comes here. That's all. ഡയറക്റ്റ് ഫോമിൽ ഏറ്റവും കോംപ്ലിക്കേറ്റഡ് ആയിട്ട് വരാൻ പറ്റുന്ന ചോദ്യം ഇതാണ്. ഇതിൽ കൂടുതൽ ഒരു കോംപ്ലിക്കേറ്റഡ് ഫോം ഇതിനകത്ത് വരാനില്ല. ഓക്കെ, എക്സെപ്റ്റ് ദാറ്റ് as I told earlier, sometimes they will not give this term. In that case, you should avoid drawing this line. Okay, അത്രേ ഉള്ളൂ. Any doubts? Okay, the next form is cascade form. So in cascade form, h of z is expressed as product of multiple terms. Each term can be realized separately. For example, h of z എന്നുള്ളതുണ്ടെങ്കിൽ you can write it as h1 of z multiplied by h2 of z up to hn of z എന്നുള്ള രീതിയിൽ എഴുതാൻ പറ്റും. ഓക്കെ, സോ ഈ ഒരു ഇക്വേഷനിൽ എഴുതാൻ പറ്റണം. ഈ ഇക്വേഷനിൽ എഴുതാൻ പറ്റി കഴിഞ്ഞു കഴിഞ്ഞാൽ then you can represent them in cascade form. So normally ഈ ഓരോ h1 h2 up to hn you will have maximum of z raised to minus 2. 3 ടേംസ് മാക്സിമം വരാൻ പാടുള്ളൂ എന്നുള്ളതാണ്. ബട്ട് ഈവൻ ഇഫ് യു ഡ്രോ ഇറ്റ് വിത്ത് മൾട്ടിപ്പിൾ ടേംസ് ദാറ്റ് ഈസ് ടോട്ടലി ഫൈൻ. ഓക്കെ, ഓക്കെ, സോ ദ കാസ്കേഡ് ഫോം ഈസ് ലൈക്ക് ദിസ്. h1 ഓഫ് സെഡിനെ ആദ്യം വരയ്ക്കുക. ദിസ് ഈസ് h1 ഓഫ് സെഡ്. h2 ഓഫ് സെഡ് അടുത്ത് വരയ്ക്കുക. ആൻഡ് ഇറ്റ് ഗോസ് അപ് ടു hn ഓഫ് സെഡ്. ഓക്കെ, ഫോം ഇങ്ങനെയാണ്. ഇറ്റ് വിൽ നോട്ട് ചേഞ്ച്. ഇറ്റ് വിൽ ബി ലൈക്ക് ദിസ് ഓൺലി. There will be a multiplier goes to the adder, delay at the bottom. Each delay will have a multiplier after that which goes to another adder, and finally the last delay element will be passed to a multiplier and goes to the adder, and this will be your cascade. First h1 of set. ഈ സെയിം ഫോമിൽ തന്നെ സെക്കൻഡും വരും. Okay, let's see an example. Obtain the cascade form realization of h of z is equal to 1 minus 1 by 4 z raised to minus 1 plus 3 by 8 z raised to minus 2 into 1 minus 1 by 8 z raised to minus 1 minus 1 by 2 z raised to minus 2. If you look at this equation, the equation is already given in cascade form. 1 multiplied by other. So 1 multiplied by other എന്നുള്ളതാണ് cascade form. അതേപോലെ ഉണ്ടാവണം എന്നുള്ളൂ. So we take the first one as h1 of z and second one as h2 of z. Okay. Then we will draw. എങ്ങനെ വരയ്ക്കും? You take the first one. Okay. So you see how many delays? 1, 2. So it will start from x of n. You draw 2 delays below. Okay. Then after the first delay, there is a multiplication by minus 1 by 4. So after the first delay, you draw a branch towards the right, put an adder and give a multiplication of minus 1 by 4. Now after the second delay, there is a multiplication by 3 by 8. So after the second delay, you put a multiplication block, multiply and give the value 3 by 8. So there is an addition of minus 1 by 4 z raised to minus 1 and 3 by 8 z raised to minus 2. So you need to add after the second delay, which is getting multiplied by minus 1 by 4. After the first delay, which is getting multiplied by minus 1 by 4, and after the second delay, which is getting multiplied by 3 by 8, you add them together. And this is added with 1. 1 means which is basically this line without any delay. That is h1 of z. Go to h2 of z. How many delays? 1, 2. So in a separate block, you will have a starting point, 2 delays, one below the other. After the first delay, there is a multiplication by minus 1 by 8. So after the first delay, you put a by a block and put as minus 1 by 8. After the second delay, there is a multiplication by minus 1 by 2. So after the second delay, you multiply by minus 1 by 2, and these two are getting added. So minus 1 by 8 into z raised to minus 1 minus 1 by 2 into z raised to minus 1 will get added here. And this is added with a 1, which means whatever is coming at this point passes through a point called as 1, which will be added with the rest. That's all. This is your y of n. Okay. Cascade form also, only thing you want to make sure is it is given as the product of two terms. അങ്ങനെ അല്ലെങ്കിൽ നിങ്ങൾ പ്രൊഡക്റ്റ് ആക്കണം. ആക്കിയിട്ട് ഫസ്റ്റ് ടേം എന്ന് പറയുന്നതിനെ നിങ്ങൾ ഇങ്ങനെ ഒരു ബ്ലോക്ക് ആയിട്ട് എഴുതുക, വരയ്ക്കുക. സെക്കൻഡ് ടേം എന്ന് പറയുന്നതിന് ഒരു ബ്ലോക്ക് ആയിട്ട് വരയ്ക്കുക. Okay. Now let's assume that in the next question it is not given in cascade form. So how will you convert it to a cascade form? So h of z is equal to 1 plus 3 z raised to minus 1 plus 4 z raised to minus 2 plus 4 z raised to minus 3 plus 3 z raised to minus 4 plus z raised to minus 5 എന്നുള്ളതാണ് എൻ്റെ h of z. ഇതിനെ h1 of z multiplied by h2 of z എന്നുള്ള രീതിയിലാക്കണം. ഇങ്ങനെ ചെയ്യാൻ വേണ്ടി ഫസ്റ്റ് ഫൈൻഡ് ഔട്ട് the factors of h of z. Factor means if you substitute a value for z raised to minus 1, or if you substitute a value for z, at what value will this equation is equal to 0? For example, let's say I substitute z equal to minus 1. Z in the value minus 1 are substituted. So I'll get 1 minus 3 plus 4 minus 4 plus 3 minus 1. So if you add them together, it becomes 0. That means z raised to minus 1 equal to minus 1 is a factor of this equation. So I can write h of z as 1 plus z raised to minus 1 multiplied by h1 of z. Karanam z raised to minus 1 plus 1 can be written as, so since you are substituting minus 1 and you get 0, then I can write h of z as 1 plus z raised to minus 1 multiplied by some quantity. Okay, But we want to find what this h1 of z is. Then only you can draw the diagram, because then only you can represent it as 1 plus z raised to minus 1 into some z transform. Okay. Now, to find h1 of z, you need to divide h of z by 1 plus z raised to minus 1. That is, you divide your original h of z, which is this, by 1 plus z raised to minus 1. Now, when you divide, I don't know whether you have studied this division, you write the original term, that is the numerator. You write the denominator in such a way that the maximum power comes at the start. So even if you write this, you see this is z raised to 0, z raised to minus 1, minus 2, minus 3, minus 4, minus 5. So the maximum power will come at the left, and you write in the decreasing order of power. So 0, minus 1, minus 2, minus 3, minus 4, minus 5. The divisor also you write in such a way that the maximum power comes to the left, and it and the rest of the terms are in the decreasing order of power. Now, what you want to do is, you want to find out what value should be multiplied by the divisor so that the first term of the dividend will become 0. If you subtract that number multiplied by divisor, the first term of the dividend will become 0. For example, if you multiply 1 with 1 plus z raised to minus 1, or if you multiply 1 with 1, then it will be 1 here plus some terms here. Okay, and if you subtract this, this will become 0. So this will become 0. So when you subtract this, you need to subtract the rest of the terms also. So you subtract 3 z raised to minus 1 minus z raised to minus 1, that will be 2 z raised to minus 1 plus 4 z raised to minus 2, the rest of the terms here. Now, the first term in the next sequence is 2 z raised to minus 1. So you find out what should be multiplied by the first term in the divisor, so that if you put it here below and subtract it, the first term of the next sequence will become 0. So you see this is 2 z raised to minus 1. So you multiply by 2 z raised to minus 1 with 1, it will be 2 z raised to minus 1 here. The rest term will be 2 z raised to minus 1 into z raised to minus 1, that is 2 z raised to minus 2. Now you subtract, so this will become 0, this will become 2 z raised to minus 2, and the rest of the terms follows. Again, in the next sequence, the first term is 2 z raised to minus 2. You find out what should be multiplied by the first term in the divisor, so that you can subtract out the first term in the second sequence. Again, to subtract out this, there should be 2 z raised to minus 2 here, which means I need to multiply by 2 z raised to minus 2 with 1 here. When you multiply 2 z raised to minus 2 with 1, it also should be multiplied by z raised to minus 1, which will come here. So 2 z raised to minus 2 multiplied by 1 plus z raised to minus 1 is 2 z raised to minus 2 plus 2 into z raised to minus 3. So this term will become 0. Again, you subtract this 2, you get 2 z raised to minus 3. So if you multiply by 2 z raised to minus 3, the 2 z raised to minus 3 will come here, it will get subtracted, it will become 0. But 2 z raised to minus 3 will also get multiplied by z raised to minus 1. So it will become 2 z raised to minus 4. And it goes on. So you can see that the denominator will become 0 at the end. So you can write h of z as 1 plus z raised to minus 1 multiplied by 1 plus 2 z raised to minus 2 plus 2 z raised to minus 3, whichever is the quotient of this division. Okay, if you want, you can still find out what can be a factor of this. I think minus 1 will again come here for this matter. Okay, so you can draw h1 of z is, the maximum power is 1, so you draw one single block. So 1 plus z raised to minus 1 means this 1 will be directly going to the adder, this will also come, so that is 1 plus z raised to minus 1. In the next block, you have you find out how many delay elements. There are 4 delay elements. You start from here. After the first block, you draw 4 delay elements, and you see after the first delay element it is multiplied by 2, so you draw a branch, it gets multiplied by 2, and you draw an adder. After second element, second delay, it is multiplied by 2, so after second delay you draw a multiplier by 2 with an adder at the end. After the third delay, again multiply by 2, adder at the end. And after the last one, you have multiplier by 1. If you want, you can draw an adder. Even if you don't draw an adder, that is fine. Now connect all the adders, because there is a 1 here, because of which it will come here also, which is your y of n. Okay. This is the cascade form of realization of Fir filter. Any doubts in this? Okay. So if you don't have any doubts, then I think we'll stop it here. You can ask the doubts. I think tomorrow we have